Good morning everyone. Let us start. Remember we have been learning chapter 6 soils. Yesterday we discussed about ICAR classification of soils. Today we shall discuss about a simplified classification of Indian soils based on genesis, color and other characteristics. Now I shall present my screen. Okay, so on the basis of genesis, that is origin, okay, mode of origin, then color, composition and location, the soils of India have been classified into the following types. Okay, so this is a simplified classification based on these genesis, that is origin, then mode of origin, color of the soil, composition of the soil and location of the soil. Okay, so we have got 8 types of soils in India: alluvial soils, black soils, red and yellow soils, laterite soils, arid soils, saline soils, peaty soils and forest soils. Okay, now let us read in detail. First we have alluvial soils, and alluvial soils are widespread in northern plains and river valleys. Okay, as you know, alluvial soils are widespread in the northern plains, in the Ganga Brahmaputra plains and in the river valleys, and these soils cover about 40% of the total area of the country. So these alluvial soils are depositional soils. Okay, so from the highlands, the rivers and running water carry down the materials and deposit it, okay, in the low-lying area, and thus form these alluvial soils. Okay, so they are depositional soils transported and deposited by rivers and streams in the low-lying areas. Through a narrow corridor in Rajasthan, they extend into the plains of Gujarat. Okay, and in the peninsular region, they are found in the deltas of East Coast and in the river valleys. So let us see the map given in your book. So this is the map given in your book, and here we have, okay, this pattern shows the alluvial soils, and see here the whole northern plains, including deltas of this West Bengal, that is Ganga. Okay, and a narrow, okay, through a narrow corridor in Rajasthan, it extends up to this Gujarat here. Okay, and here it is in Punjab area and in Brahmaputra Valley and in the coastal areas. Okay, here in the coastal areas also, so we find these alluvial soils. Okay, and the alluvial soils vary in nature from sandy loam to clay. So this is about the characteristics of the alluvial soils. So alluvial soils vary in nature from the sandy loam to clay. Okay, see here, we may see this soil texture triangle. Okay, so this is the soil texture triangle, and just see here, sandy loam is here. Okay, sandy loam, and here sandy loam, in case of sandy loam, the sand contain, see here, okay, the sand contain is between 70, okay, to around 50%, that is from 50 to 70% the sand content. And this clay content is very low, okay, that is between 15 to 20%. Okay, and this silt contain, okay, somewhat higher. Okay, so this is for the sandy loam. Remember, we have three main soil materials, okay. Those are these silk, okay, silk, then sand, okay, silk, sand, and the clay. So these are the three important components or the soil materials, okay. And the percentage here of these three components determine the type of the nature of the soil, okay. And so in case of sandy loam, the percentage here of sand is very high, ranging between 50 to 70%, okay, to clay. So for the clay, it is here, just see this area here. In case of clay soil, this percentage of sand is very low in this case, okay, mainly composed of clay. Just see this triangle. And let's continue. And they are generally rich in potash but poor in phosphorus. Alluvial soils are rich in potash and poor in phosphorus. In the upper and the middle Ganga plain, two different types of alluvial soils have developed, namely Khadar and Vangar, that you have learned earlier in the previous classes. Okay, in the upper and middle Ganga plain, two different types of alluvial soils have been developed, Khadar and Vangar. Okay, upper and middle Ganga plain is here in this area, okay, here in this area, that Uttar Pradesh and Bihar area. And so the Khadar is the new alluvium, and it is deposited by flood annually, which enriches the soil by depositing fine silt. And Vangar represents a system of older alluvium deposited away from the floodplains. As you know, alluvium, newer alluvium is locally known as Khadar, whereas the older one is known as the Vangar. Okay, and Khadar is more fertile than the this Vangar because it is enriched. Okay, this Khadar is enriched by the flood waters every year. And just see here about this location, okay, about the location of Vangar and Khadar. So let us say these are the river terraces, and here we have the river, okay, and again these are the terraces, and let us say this is the levee, okay, and here we have another levee. So this is the river, okay, this is the river, and this area, this low-lying area nearby the river is known as the floodplain, okay. And when the river is in flood, okay, the flood water will overflow the levee and this area will be flooded, okay. And because of this flooding, these soils found here will be enriched, and this type of soil is known as Khadar, whereas the Vangar lies, okay, away from the river at these upper these terraces, okay, on the river terraces, away from the floodplains, okay, in the higher reaches of the river valley, okay. So remember, here we have Khadar, and away from this soil we have Vangar, okay. And these soils are more loamy and clayey and in the lower middle Ganga plain and Brahmaputra valley. So alluvial soils are more loamy and clayey. That means the percentage of clay is high, okay, and the percentage of silk is high in the lower and the middle Ganga plain and the Brahmaputra valley. And the sand content decreases from west to the east. So in the west, just see the map. So in the west, here in the western part, here the sand content is very high, and the sand content decreases from west towards the east in this way. Okay, here the sand content is very low. That means the clay content and the silt content is high. And about the color of the alluvial soil, okay, alluvial soils vary from light gray to ash gray, and its sets depend on the depth of the deposition, the texture of the material, and the time taken for attaining the maturity. And you know, alluvial soils are intensively cultivated in the northern India, okay. And about the color and about the these alluvial soil, see here, this is a profile of alluvial soil, okay, and you may be seeing that the color of the alluvial soil, as mentioned in the book, is light gray to ash gray, okay, like this. It is like this. And next we have another type of soil, that is black soil, okay. And black soils cover most of the Deccan Plateau, which include parts of Maharashtra, then Madhya Pradesh, Gujarat, Andhra Pradesh, and some parts of Tamil Nadu. In the upper reaches of Godavari and Krishna, and the north western part of the Deccan Plateau, this black soil is very deep. Okay, now let us see a map, and see here, if you see this map, then black soil is here, okay. The color which is representing black soil is here. And if you see this map, see here in Gujarat, this area is covered by black soil, and here this is the Deccan Plateau area, okay. And just see here, so we have Madhya Pradesh, Maharashtra, then northern Karnataka, then Telangana area, okay. And we find some patches also, see here, some patches of this black soil is found here in Jharkhand area, okay, and in Gujarat also, and in the other part of Karnataka also we find these patches of these black soils, okay. And these soils are also known as rigor soil locally, okay. These black soils are locally known as rigor soils or black cotton soil, because this soil is very much suitable for cultivation of cotton. And about the characteristics of the black soils, the black soils are generally clayey, deep, and impermeable, okay. It consists mainly of clay, okay. Then it is very thick and impermeable, that it is very difficult to pass through by water, okay. Impermeable means difficult, or water cannot pass through, but it can pass through, but difficult. It takes time to absorb the water, and they swell. These black soils swell and become sticky when wet and shrink when dried. This is another characteristic. When black soils are wet, it becomes sticky, okay. It is swollen and sticky, and when it is dried, it is shrink, okay. And so during the dry season, these all develop white cracks, and thus there occurs a kind of self-ploughing. Remember, see black soil. This is a photograph showing black soils, okay. See the color, it is almost a dark gray or black, and when it is dried up, it develops big cracks, huge cracks like this. And it is also here in our textbook also, figure number 6.3, shows the development of cracks during the dry season in the black soil, and this phenomenon is known as self-ploughing. Because of this character of low absorption and less loss of moisture, and the black soil retains moisture for a very long time. This is another characteristics of black soils. Black soils can retain water for a very long time because these soils absorb water slowly and lose water slowly. Black soils absorb water slowly and lose the moisture slowly, and therefore black soils retain moisture for a very long time, and helps the crop, especially the rain-fed ones, to sustain even during the dry season. So these are the important characteristics of black soils. Chemically, these black soils are rich in lime, iron, magnesia, and alumina, and they also contain potash, but they lack in phosphorus, nitrogen, and organic matter. And about the color of the black soil, actually deep black to gray. The color is from ranging between black to gray. So any question? Are you clear?
Yes, sir.
Then let us continue. Next we have red and a yellow soil. So red soils develop on crystalline igneous rocks in areas of low rainfall. Remember, red soils are developed on hard igneous rocks in areas of low rainfall in the eastern and the southern part of Deccan Plateau, along the Piedmont zone of Western Ghat. Piedmont zone means foothills, of the Western Ghat. Then long stretch area is occupied by the red loamy soil. That is, along the foothills of Western Ghat, long stretch area is occupied by the red soils, red loamy soil. And yellow and red soil also found in Orissa and Chhattisgarh, and in the southern part of the Middle Ganga Plain. Now let us have a look of the map. See here, this red and yellow soil, the color which is representing red and yellow soil is here, and red and yellow soil. I think you are seeing here these areas, red and yellow soil area. These Jharkhand area, part of West Bengal, then Orissa, Chhattisgarh, then eastern part of Madhya Pradesh, then eastern part of Maharashtra, then this most state of the Northeast India, Mizoram, Manipur, Nagaland, then this Arunachal Pradesh, southern part of Arunachal Pradesh. Here in the South India also, see southern part of Andhra Pradesh, then western part of Tamil Nadu, then Kerala, Karnataka. So this is along the foothills of the Western Ghats. So in these areas we find red and yellow soils. And this soil develop reddish color due to a wide diffusion of iron in crystalline and metamorphic rocks. Why red soils are red in color? So this is because of diffusion of iron in crystalline metamorphic rocks. That is oxidation process. It contains iron, and due to oxidation, so it gives the color red. And it looks yellow when it occurs in hydrated form. So when it absorbs water, and there will be chemical reaction this in the soil, and that process is known as hydration. Okay, because of hydration reaction, okay, it looks yellow. So it is a reversible reaction. Okay, and the fine grain red and yellow soils are normally fertile, whereas coarse grain soils found in dry uplands are poor in fertility. Remember, fine grain red and yellow soils are fertile. Fine grain means the size of the particle is very, very small, whereas the coarse one, the bigger one, normally not fertile. Okay, and red and yellow soils are generally poor in nitrogen, phosphorus, and humus. And so about the red soils, okay, so for the red soil, so this is a photograph showing red soil. Okay, here the color of the soil, as you know, as you are seeing here, it is almost red. Okay, so this is also no, this is not red soil. Okay, so next we have another type of soil that is known as laterite soils. And laterite, the word laterite has been derived from the Latin word later, which means a brick. Okay, and these soils develop in the areas with high temperature and high rainfall. Remember, for the red and the yellow soils, it is developed in the areas of high temperature and low rainfall. But for the laterite soils, these are developed in the areas of high temperature and high rainfall. Okay, and these are the result of intense leaching due to tropical rains. So laterite soils are formed by leaching process. With rain, lime and silica leach away, and the soils rich in iron oxide and aluminum compound are left behind. You know, leaching process, actually see here, say, let us say this is the, okay, this is the surface, and this is the topmost soil, let us say. Okay, let us say A horizon, for example. Next we have the B horizon, and so here the topmost layer, that is the A horizon, contains lots of nutrients and minerals, and due to the heavy rainfall, okay, in the tropical areas, due to the heavy rainfall, the rainwater will dissolve the minerals found in the soils and will be carried downwards. Okay, and will deposit in the this B horizon and the C horizon, and this process is known as leaching. Okay, and due to leaching, this iron oxide and this one lime and silica are leached away. Okay, thus leaving iron oxide and aluminum on the surface, that is in the topmost soil. And the humus content of the soil is removed fast by bacteria that thrives well in high temperature. Humus, you know, the partly decomposed organic matter is decomposed fast by the bacteria that thrives well in the high temperature. And laterite soils are poor in organic matter, okay, then nitrogen, then phosphate, and calcium, while iron oxide, then potash are in excess. Okay, as mentioned earlier, due to leaching process, in the topmost soil we find mainly iron oxide and aluminum compound, as well as potash. Okay, so in this soil, iron oxide and potash are in excess. Hence, laterite soils are not suitable for cultivation. Okay, application of manures and fertilizers are required for making the soils fertile for cultivation. And laterite soils in Tamil Nadu, Andhra Pradesh, Kerala are more suitable for tree crops like cashew nuts. So laterite soils in Tamil Nadu, Andhra Pradesh, Kerala are more suitable for tree crops like cashew nuts. Laterite soils are widely cut as bricks for the use of house construction, and these soils have mainly developed in the higher areas of Peninsula Plateau. The laterite soils are commonly found in Karnataka, Kerala, Tamil Nadu, Madhya Pradesh, and the hilly areas of Odisha and Assam. So let us see this map again. Here this color, okay, shows laterite soils, and here you may find patches of laterite soils here in Tamil Nadu area also. Then in the Western Ghats also see here, western part of Karnataka, then Goa area, then Maharashtra area, okay. And here in Northeast India also, in Meghalaya also, see here in Meghalaya also we find laterite soils. Then in the lower Assam we find laterite soils, okay. And here also these in the southern part of Rajasthan also we find laterite soils. And in patches, okay, in almost all the big states of India we find patches of these laterite soils. Here in Odisha also, then here in Telangana also we find laterite soils, okay. And about the color, it is almost the same with the red and the yellow soil. See, this is a photograph showing laterite soils, okay, a highly lit soil. Next we have these arid soils, okay. These are the soils found in the deserts, and arid soil ranges okay, from red to brown. For the color, arid soil ranges from red to brown in color. They are sandy in structure and saline in nature, okay. You may see this soil texture triangle, and see here this the location of the sand is here, okay. And so this is sandy soil. Here the sand content is more than 80%, and the clay content is less than 10%, okay. Clay content is less than 10%, and it is saline in nature. It contains salt, and in some areas salt content is so high that common salt can be obtained by evaporating the saline water. So after boiling the saline water we can get salt, that is sodium, okay. Due to dry climate, high temperature, and accelerated evaporation, they lack moisture and humus. That means arid soils contain less humus, that is organic matter, and less moisture. And nitrogen is insufficient, okay. And the phosphate content is normal. And in the lower horizons of the soils are occupied by these conker layers because of increasing calcium content downwards, okay. Conker, you know, calcareous material, grains of this calcium carbonate, okay, locally known as conkers. So it is found in the lower horizons, okay, in the B and the C horizons. And the conker layer formation in the bottom horizon restrict the infiltration of water, and as such, when irrigation is made available, the soil moisture is readily available for sustainable plant growth. Arid soils are characteristically developed in the western Rajasthan, which exhibit characteristic arid topography. And I think you are very much familiar with these sandy soils or the arid soils, as we are seeing in the movies also. And these soils are poor and contain little humus, as mentioned earlier, and organic matter. Okay, so about the location of these arid soils, you see here, western part of Rajasthan, see here. In this area we find arid soils, okay, in this area only. And about the see arid soils, so this is just an example, okay. It contains a lot of sand, more than 80%. And next we have the saline soil. Okay, this is another type of soil, saline soils, and they are also known as Ursara soils, that is sterile. Okay, saline soils contain a larger proportion of sodium, potassium and magnesium, and thus they are infertile. So it contains a large quantity of salt, different types of salt like sodium salt, potassium salt and magnesium salt. Okay, and they do not support any vegetative growth, and they have more salt largely because of dry and poor drainage. Okay, poor drainage means this water cannot be drained away very easily, and they occur in the arid and semi-arid regions. Actually, saline soils are found in the deserts and semi-desert areas, and as well as in the waterlogged and swampy areas. Okay, and their structure ranges from sandy to loamy, and they lack in nitrogen than calcium. And saline soils are more widespread in western Gujarat, okay, than deltas of eastern coast, than Sundarbans of West Bengal. In the run of Kutch, the southwest monsoon brings salt particles and deposits there as a crush. And now let us see that map. Okay, just see here, run of Kutch is here. Run of Kutch is here in this area, and first here saline soil is not located here, but this run of Kutch is here. Okay, so here in this area we find saline soils, and here in Rajasthan also we find some of the sandy soils are saline, and as well as this in the delta areas here. Okay, in the delta areas of West Bengal, as mentioned above, we find saline soils. Okay, in the Sundarban delta of West Bengal we find saline soils. Then western part of Gujarat, as I told you, this area. Okay, and you may find some saline soils in Punjab also due to intensive irrigation. Okay, and seawater intrusion in the deltas also promote the occurrence of saline soils. And in the areas of intensive cultivation with the excessive use of irrigation, especially in the areas of green revolution like Punjab, Haryana, okay, the fertile alluvial soils are becoming saline. Excessive irrigation with dry climatic conditions promote capillary action, which result in the deposition of salt on the top layer of the soil. Capillary action, you know, this is the opposite of this leaching. Okay, just see here, for this is about leaching. For the capillary action, just see here, it is occurred mainly in the dry areas. This is in the wet areas, in the tropical rainy areas. For the desert areas, okay, see here, from the groundwater, from the aquifer, from the lower areas, water will rise upwards due to capillary action of the soil, and this water will dissolve the salt found here, different types of salts found here, and will carry and will reach the surface. And when it reaches the surface, due to the bright sunshine, okay, the water will be evaporated and the crystals of salt will remain on the surface, and thus the surface become saline, the soil becomes saline. Okay, so this is due to the capillary action. And here in such areas, especially in Punjab and Haryana, farmers are advised to add gypsum to solve the problem of salinity in the soil. Just to solve the problem of salinity, okay, in this type of soil, we have to add gypsum. Okay, and we have a photograph showing this saline soil here. So this is a photograph showing saline soils, okay, in these wet areas. So let us finish the types of soils. Okay, bear with me. Next we have PT soils, and they are found in the areas of heavy rainfall and high humidity where there is a good growth of vegetation. Just see the photograph here. Okay, so this is a photograph showing this PT soil. It is found in the wetlands. Okay, and here we have another photograph showing these PT soils. Okay, it is mainly found in the wetlands and where there is thick vegetative growth, and thus large quantity of dead organic matter accumulates in these areas, and this gives a rich humus and organic content. That means in the PT soils the organic content is very high. The organic content in these soils go even up to 40 to 50% in case of PT soil. Okay, and these soils are normally heavy and black in color. At many places they are alkaline also. Okay, that the pH value is less than 6.5. Okay, and it occurs widely in the northern part of Bihar, then southern part of Uttarakhand, then coastal areas of West Bengal, then Orissa and the Tamil Nadu. Let us see whether it is there or not. Okay, it is not here. And another map is there. Okay, it is also not here, but you may locate it. Okay, using LS. This part of Uttarakhand, then coastal areas of West Bengal, Orissa and Tamil Nadu. In Manipur also we find PT soil in and around the Loktak Lake. Okay, where there is wetland. And the last type of soil is known as the forest soils. Okay, as the name suggests, these forest soils are formed in the forest areas where sufficient rainfall is available. So we may locate it. Just see here, the green color represents forest and the mountain soils. So we find forest and the mountain soil here in Sikkim, then northern part of this Arunachal Pradesh, then Jammu and Kashmir, then Ladakh, Himachal Pradesh, Uttarakhand. So in these areas we find these forest and mountain soils. Okay, these soils vary in structure and the texture depending on the mountain environment where they are formed. They are loamy and silty on the valley side and coarse grain in the upper slopes. Just in the valley side, okay, just let us say this is a mountain. So in the low-lying area, so in the valley side, here it is loamy and silty. In the upper slope here, it is coarse grain. Okay, see here in the upper slope, it is coarse grain, and in the low-lying area, loamy and silty. And in the snowbound areas of the Himalayas, they experience denudation, that is erosion. Okay, process, and are acidic with low humus content. Acidic, that is the hydrogen ion concentration, that is the pH value is less than 6.5. And so for the alkaline, okay, the pH value is more than 6.5. If the pH value is less than 6.5, we call it acidic. Okay, there was a mistake about when I explained about the this PT soil. Okay, and the soils found in the lower valleys are fertile. The soils found in the lower valleys in the mountainous areas are fertile. Okay, so these are the different types of soils found in India. Okay, any question?
No, sir.
Okay, then let us stop here for today. Thank you very much for joining my class.